Now we'll talk a little bit more about properties of R, the correlation coefficient. What we know so far is, first, units of measurement do not affect the value of R. So you change from feet to meters or something like that, and it's not going to affect it. Now we examine a second property of R. The second property is use R only when the form is linear. The correlation measures only the strength of a linear relationship between two variables. It ignores any other type of relationship, no matter how strong it is. For example, curvilinear relationships and R. The relationship between the average fuel usage that we've seen in a previous example earlier in this module of driving a fixed distance in a car and the speed at which the car drives has a curved form. The relationship is very strong because the data follows the curve perfectly. So whatever this curve is, I don't know how it's modeled. It's definitely not a line, but maybe it's part of a different type of function or curve that you might have seen in algebra. It's definitely not a line. But if you were to do that formula anyway, the formula for R that we saw with the big sum and the fractions in parentheses and all over n minus 1, that guy, you would get this R value here. Okay, well, let's see what we say about it. We should not use R in this situation. Why? Because notice that the correlation R equals negative 0.172 indicates a weak linear relationship. So because it's close to 0, remember when R is close to -1 or +1, it's really close. And when I say close, I guess that's a relative term, but you got to use your best judgment. When the closer it is to those, the stronger the relationship between the data and the line. Between data and the line. But on the other hand, if R is close to 0, in either direction, if it's a negative number that's close to 0, kind of like this R that we have in this example, or if it's positive, doesn't matter. It's not much strength. It won't. That means the linear relationship doesn't really work very well. Not much strength. This example illustrates that the correlation coefficient is useless as a measure of strength if the relationship is not linear. It also illustrates an important rule. Always make a scatter plot of the data before calculating and interpreting the meaning of R. If the form is not linear, don't use R. You might come to the wrong conclusion. You got to make sure it looks linear first and then go ahead and try to find R if it looks linear.